Hello everyone, my name is Abhishek. I'm a PhD student from Purdue University. I'm very excited to be presenting our research work today and would love to hear some feedback on that. I also want to thank IEEE Sensors for this wonderful opportunity. The topic of our paper is magnetic position tracking using inductor coils and IMU. The other contributors to the paper are Mohit, Singh and Byunghoo, Jung. To give a gist first, the system we developed achieves three-dimensional position and orientation tracking of a tri-axis receiver inductor coil with respect to a single-axis transmitter inductor coil. The inertial measurement units and microcontrollers as well to achieve this. The system thus achieves a position jitter of less than 1 millimeter up to 1 meter distance. To talk about the applications of such a system that achieves personal area tracking, which is a radius of about 1.5 meters, there are numerous applications ranging from augmented and virtual reality, where most of the focus is at, then there's body motion tracking for sports, training purposes, medicine, etc. The advantages of magnetic position tracking systems include no line of sight problems, something that most of the other tracking technologies face. It's robust to multipath effects, it's computationally less intensive, so highly responsive. The systems also tend to be cheaper. Let's move on to the working principle. The transmitter and receiver are in arbitrary orientations. The relative orientation between them is found using an orientation algorithm. The received magnetic field is then rotated to align the coordinate frames of the transmitter and receiver. The three equations of a point source magnetic field are then solved to find the position. The data is communicated out through USB. This is a constructed receiver, and this is the transmitter module. You get an idea of the form factor here, which is quite small. To talk about some of the important challenges that the seemingly simple system is fraught with, the estimated position is very sensitive to the transmitted power, which may change due to temperature, ferromagnetic materials in the vicinity. So the power is strictly regulated using a closed loop PWM based control as shown. The other challenge we faced was to synchronize the magnetic field phases between the transmitter and receiver, which is required to reduce the ambiguity in the positions. This is achieved using a Bluetooth radio by diligently profiling the timing for communication and keeping track of the phase. Finally, these are the results. The position jitter is within 1 millimeter for distances up to 1 meter, after which it worsens due to the drastically diminishing SNR. The accuracy is within 1 centimeter. The features of the system are that it is compact, lightweight, and wireless. It has a maximum latency of 5 milliseconds. It is inexpensive and has no line of sight problems. Thank you so much for listening to the presentation. I would be happy to answer any questions that you may have to the best of my abilities.